right. All right, let's get started. Welcome, everyone. How do you like Build so far? Good? Awesome. It's one of my favorite conferences always. So my name is Rong, and I am a program manager on the Python team at Microsoft. So I just recently moved from the C++ team to join the Python team because it's getting so popular. I just want to see what is this all about. So I primarily work on the Visual Studio Code experience for Python around data science, machine learning. And I'll let Catherine introduce herself.
Yep. Hi, everyone. I'm Catherine Kampf. I'm a program manager on the Python tools team as well, working specifically on a product you'll see today called Azure Notebooks. So we're going to start off with actually showing you what we're building today. So if you're walking around Seattle, I'm sure you've seen we're a very pet-friendly city. So we're actually going to be building a pet breed detector today, specifically for dogs and cats. So I'll start off by showing you this end result. Can people see in the back? Let me zoom in a little bit. So this is a Jupyter notebook, and we'll talk more about what Jupyter notebooks and what Azure notebooks are real quick. But I can easily run a cell just using Shift-Enter. And it's going to output the photo of the dog that we're looking at. So this is a little chihuahua I just found on the internet. And if I run this cell, it's going to send it up to the web service we've deployed. So based on the training data we'll walk through today, we've deployed a web service, and we can see the prediction. It's about 99.7% confident that it's a chihuahua, so it's correct. And we're going to be walking through our exact steps to get here, and each piece of the machine learning workflow and what decisions we made along the way. So just for a quick agenda, oops. Okay, so we'll start off by talking about how we think about classifying cat and dog breeds. When you're looking at two very similar looking dogs, how can a model learn the intricacies that determine one breed versus the other? The overall machine learning workflow, and most of our time will be spent walking through the demo and each segment of code, and then hopefully we'll have a few minutes left for Q&A, but either way we'll stay around afterwards.
All right. So first of all, can I get a quick show of hands? How many of you have done machine learning or deep learning already? Oh, OK. So that's a good percentage, about, I would say, 30%. Cool. So we'll go through these high-level concepts and techniques fairly quickly as setting up the context for how we're going to do the dog and cats classification demo today. So how do we classify these cats and dogs of different breeds? Some of these look so similar that it is almost impossible to tell them apart. For example, the dog pictures on the screen. Those dogs look so similar. For myself, I cannot tell for sure. So I'm going to rely on machine learning and to train a model that will be able to tell us the different breeds of dogs and cats. So the basic concept here is fairly straightforward. The idea is we want to be able to send a dog or cat picture to a machine that understands what those dogs and cats should look like and be able to tell us a result at the end. And this machine in the middle, we call that is kind of described as a black box. And this technique is called deep learning. What's special about deep learning is we don't really know what is in the black box. We know the input, we know the output, but how machine does training, how does it do classification, we don't really know. In deep learning, you can't trace back to the features that lead to the prediction. So that's the beauty of deep learning, but also brings in uncertainty in like how training and learning actually works. So if you think about deep learning, look more into the black box, well, we can't say we know nothing about it. We know something. Deep learning relies on a technique called deep neural network. That has multiple layers in between, and then each layer takes an input and gives an output to the next layer next layer to text input and learn out more features. So if you think about a facial recognition example, in the first few layers, it only understands the very basic shapes, like curves, edges, shapes like that. But then as it moves on to the middle layers, it will start to understand the parts of the faces, like ears, eyes, stuff like that. And as you move towards the end of the neural network, it starts to put together more complex expressions on the faces. That's how it learns more and more as it goes deeper into the neural network. And this is modeled after human brains, if you think about how we learn things. And then as you can see in the middle, in the black box, the machine does actually two jobs. The first one, it does training by itself. It does training, it trains itself by learning from the massive amount of data we feed it. And the second thing it does classification by itself as well. So why do we like deep learning? Because it's more work for the machine and less work for the human, and who doesn't like that? If we compare that with traditional machine learning, as example here, you will see that the first step, which is feature extraction, involves a lot of manual efforts. Not only it's time-consuming, it also requires domain expertise. Manually, human would have to go in there, identify features to feed into the machine learning algorithm. And there's also, as a human, you need to figure out which algorithm works the best and which parameters you want to use. So it's a lot of tuning back and forth, a lot of human efforts involved. As opposed to deep learning, we just feed the machine with tons of data and asking it to try to figure out a general pattern based on the data. So now let's talk about this demo-specific network. So there are multiple neural networks in deep learning. So you can choose different networks for different problems you want to solve. In this particular case, we are looking at a classic image classification problem. And convolutional neural network is by far the best machine learning model for image classification. And this is what we're going to use today. So it works at high level, oversimplifying things, but at high level, this is how it works. So it starts with an image. And then we preserve the RGB channels of that image over, and we feed it into a convolution layer. The convolution layer basically looks at all the inputs, data, and then try to figure out which one of those data points are important for the images that come in. So we reduce the number of inputs at this layer, but we need to reduce it further by going through this pooling layer. What this does is it looks at all the important data points, try to condense them in using some algorithms. So we have less data points that will go through this fully connected layer, neural network layer. Why? Because it is computationally expensive. If the deeper the neural network is, the more layers it has, it takes longer to do the full training. So we want to condense the data points, and we want to choose wisely in terms of how many layers we want to have in that neural network. The more, the better for results, but also costs more time. So at the end of the fully connected layer, the machine is now fully trained and be able to classify if it's a dog picture or cat picture. And in our case, this model is going to be able to do more than that. It will be able to tell us, as Kathleen demoed earlier, the breed of that dog or cat. But at high level, this is how it works. All right, so let's now walk through the end-to-end workflow in machine learning, and this is also what we're going to walk through in the demo in the next 30 minutes. So you start with data exploration, right? There's a lot of work that would go into that phase. You have your raw data. It could be in different formats. You could have multiple data sources. and you might want to clean them up, you want to transfer the data somehow, explore the data, and try to figure out, make sense of the data. So a lot of work is going to be in there. And the next step is once you have well-structured data, you feed that into, in our case, a deep neural network for training. So, and then when it's trained, the final step is now we have a model that's trained, now let's start using it. So this stage is called what we call inferencing. This is when we use the model to make predictions. If we break down the last two steps, for training, the concepts we need to think about, for one, it needs a training script because the machine needs to know what to do, what needs to be trained, and then the compute. So oftentimes, especially for deep learning, because it's computationally expensive, you often need pretty powerful machines, and sometimes could be remote, could be in the cloud. You might need more than one machine running at the same time. So stuff like that is what we call compute. So we're going to talk about that in the demo as well. Tuning is about once you have the initial model built, you look at the accuracy, you may or may not be happy with that accuracy. So you want to keep tuning and until you have a better model that has better accuracy. So that tuning process we're going to talk about as well. Finally, when we get to inferencing, you're ready to take that model and put into production. So we're going to talk about how we do that with Visual Studio Code later in the demo. And of course, you have the model file that's as an outcome, output from your training process. And then we will put that into the cloud, wrap it with a web service. And that's the final service we're going to test with a test application. So as you have already seen in the demo earlier, what we're going to do at the end is we're going to send a dog picture over to that service, and the service is going to return the prediction result for the breed. And throughout that whole workflow, along the way, we're going to use a few products and services to help us make this whole workflow easier. So first, we're going to use Azure Machine Learning Service to help us manage a lot of the parts in this workflow. We're going to use, on the tooling side, we're going to use Azure Notebooks and Visual Studio Code for a lot of the tasks in those stages. So let's start with data exploration.
Yep, so with any machine learning workflow, you're going to want to start with the data. And in this case, we're using this Oxford Pets Dataset. It's 37 categories, so that's 37 breeds of dogs and cats with about 200 images for each class. And I'd also recommend you check out the link to try out the Pets dataset, but I'd also want to point you to Azure Open Datasets. So this is a Azure site where we upload a bunch of open source data sets that you can download and play around with when you're getting exposed to machine learning or trying a new model out. So to explore this data and get a better sense of it, there's a bunch of great tools you can use, depending on the structure of your data, the size of it, and in this case, we're going to be using something you see on the right called a Jupyter Notebook. And I just want to get a sense, how many people are familiar with Jupyter Notebooks? Okay, cool. So Jupyter Notebooks are a super easy way to integrate markdown text or visualizations, videos, links, photos, etc., all alongside executable code. So this makes it a super easy way to share your work, collaborate with others, present results, etc. So it's become pretty popular in the data science community for tracking your history as you explore data. If you visualize numeric data with different plots and start to see trends and different commonalities, and you can track your whole workflow as you go through that process. And we're going to be using specifically a service called Azure Notebooks. So this is an Azure-hosted Jupyter environment. It's free to use, no setup required. Basically, we set up Python environments running in containers in Azure, and they've got a bunch of popular data science dependencies already pre-installed. So it's very lightweight for you to get started and not have to deal with setup and get straight to code. So I'm going to switch over to the demo so I can show you a bit of what that looks like. Oh, and I'll also point out, so this is the GitHub repository we're going to link you to at the end of this slides that all of this code is in. And if you scroll down here, you can just hit this launch badge, and that'll import it into Azure Notebooks as a new project. So we want to make it easy for you guys to actually run this demo yourself. So it should be fairly straightforward, but let us know if you have any issues. And once that is imported, you can see it'll appear here as an Azure Notebooks project. And we'll go specifically into this demo notebook. So as we mentioned, we're using this Oxford Pet Dataset, and let's get a sense of what the structure of that dataset looks like. So if we just do a quick ls, we can see all these different folders which represent the names of each breed, and within those are the 200 images. So if I want to get a visual sense of these, I'm actually going to run all the cells here, but to get a visual idea of what these pets look like, I can run this plot function that I wrote earlier. And so this will show you exactly what the breeds we're looking at. So we've got pugs, Samoyeds, a few cat breeds, Maine Coons, etc. So all those 200 images of each of those pets within those 37 folders. So now that we know a bit about what our data looks like, we can get into the training flow. And so as we mentioned, there's 200 images, which might seem like a lot, but with deep learning, it's really not. You need a large amount of data and a large amount of compute power, ideally. But since we only have this smaller data set, we're going to use a technique called transfer learning. And what transfer learning lets you do is take a pre-trained model so that someone else has spent the time and money to train with thousands of images, and it lets you retrain that last image specific to your data set. So this is a general image recognition model, and the last layer will bring it specifically to these 37 pets. So I just ran some code here to do that transfer learning, and hopefully it's done now. So we can see here it took about 26 seconds to run, pretty fast, and we got up to 78, almost 79% accuracy. So this is super cool. In less than 30 seconds, we were able to get something that's nearly 80% accurate. If you think about just 7 years ago when this data set was released in 2012, even the best data scientists using more compute time, more resources could only get to around 59% accuracy. So we've come a long way. But 80%, pretty solid, but we want to see if we can get this a little bit more accurate. And this is where we're going to bring in hyperparameters. So as Ron talked about earlier, there's a few different components of a neural network that you can distinguish beforehand, such as how many hidden layers you want to see, or in this case, what the learning rate is. So a learning rate is basically how much we're going to let a node weight vary in between different iterations, so how quickly we're going to learn. And there's a few techniques to try out different learning rates, but it often comes to be the case that you'll find yourself for leaping through a bunch of different values, seeing which by luck of the draw gives you the best accuracy, and going with that. So Azure Machine Learning actually has a really easy way to do this. So we can use a tool called Hyperdrive to submit this training job to a bunch of different nodes. So I have a 4-node GPU cluster up in my Azure subscription, and I can send this job to each individual node to try out a bunch of different learning rates. So this is specifying our exact learning rates here. Let me zoom in a bit if you can't see in the back. So it's going to try out random uniform values in this range, run the same training job, see which one gets the most accuracy. And we'll do a couple smart things, such as this early termination policy here. So that's a trick we can use to say we're seeing a really bad run and it's more than 15% away from our current best accuracy we've seen. We can just cut that run early and free up that compute resource to be used with a new learning rate and a new run. So I started this running earlier so we can see the output logs as things come in. We've got 4 nodes running, and here we can see our completed and running nodes. And I'll zoom out a bit for this graph. So as we go through, we can see the different best metric, and we've set the best metric to be validation accuracy, but you can configure this specifically if you want like area under the curve or a different metric, you can configure that. And as this runs, we can see the different validation accuracies we're seeing and the different run numbers here, and learning rates down here plotted with accuracy. So super useful widgets integrated right into your notebook. This whole process takes around 20 minutes to run through all the runs, so I'll save you the time, and I'm just going to use a run from a previous time that I ran this notebook. So that's what this run ID is right here. And we can evaluate this and see we got a final accuracy of around 90%. So with just an extra 20 minutes, we were able to increase our accuracy 10%. So now we've got a pretty accurate model in just a few minutes. And then I can register this run with the Azure Machine Learning Service, which will make it accessible to anyone who works within my workspace, or if I want to access it from VS Code for deployment, etc. So I'm going to switch back to the slides to summarize what we just went through. Okay. So after data exploration, our next step was training. And for training, we used an approach called deep learning. And as we spoke about, deep learning relies on huge amounts of data. That's where it really thrives, with a bunch of training data where it can do automatic feature extraction on raw data. But of course, this is super computationally expensive and time expensive. If you think of a model like Google's AlphaGo, that's going to take months of time and thousands of dollars of compute power. But I don't know about your bosses, but my boss wouldn't be very happy with that. So instead, we're using transfer learning. And for this, we just used a pre-trained model, the MobileNet, and retrained it specifically to our data set. And we were using Azure Machine Learning for that, and specifically the TensorFlow framework. So these are all of the supported frameworks with Azure Machine Learning, but there's a bunch of other ones I'd encourage you to explore. We chose TensorFlow because it's become a very popular deep learning library. I'm sure you folks have heard of it before. And because of that, it's got a really strong community on Stack Overflow. It's got a bunch of great samples. We were able to take one of the standard TensorFlow image recognition samples and modify it slightly to work with our example. But because of all those great resources, it makes it super easy to get started. But I definitely encourage you to try out a bunch of different frameworks. They're all pretty cool. Personal fan of Keras, but and specifically on TensorFlow, it's written in Python and C++, which is great because we have Rong, and she came from the C++ team and now works on Python. And then we use the pre-trained MobileNet, and TensorFlow automatically understands MobileNet, so we can set that in this line here, and it'll know to use that as the reference point. So after we got there with our 80% accuracy, we then could hyperparameter tune using Azure Machine Learning Service. Azure Machine Learning Service is an Azure offering that manages your end-to-end machine learning workflow and has a bunch of different easy integrations along the pipeline. So for instance, if you're new to machine learning, there's a drag and drop experience where you can essentially upload a data set, point at a column you want to train on, and it'll handle the rest. It'll try out like hundreds of different algorithms, see which one gets the best accuracy, spit that out to you, and you're good to go. Similar to what we were able to do with hyperparameter tuning. And the hyperparameter tuning we are also running on a cluster compute. So this was a 4-node cluster I spun up in Azure, but what's super nice is that AML manages all that compute. I don't have to worry about if my nodes are up and running. It takes care of that, and you can
scale down to 0 if you don't have any job running, so you don't pay. So
exactly, yeah. So once you create the cluster, you can set min and max nodes. So I always set my min as 0. So this morning, I had 0 nodes, so I wasn't getting charged, but I could spin it up to 4 quickly for this demo, which is super great for cost management. And as Rong's going to show, it also does really easy model deployment. So I'll switch over to her to take over for inferencing.
All right, let's talk about inferencing. So we're going to talk about 2 things in here. So Jupyter Notebook is great, like for what Kathleen just showed you, for data exploration, for training, and comes with full interactivity, and it's super powerful. But when it comes time to take our experimentation into production, I would rather work in an editor, a developer tool that would make me more efficient. So we're going to talk about productization with Visual Studio Code, and on the other hand, we're going to also talk about model management and registration and deployment, how we take a model and eventually turn that into a service. All right, let's switch over to my demo machine. All right, so here's Visual Studio Code, and my starting point is the notebook file that Catherine had been working on in Azure Notebooks. So I simply clone that GitHub repo in here in VS Code, and you see I have this notebook file here. So what I'm going to do is to click on that. You see the notebook file be opened, but also what's more interesting is down here we have a dialog box that's asking me if I want to import the Jupyter Notebook into VS Code. So let's do that. Let me click on import. So what's happening is we extract all the code from your notebook file and put everything into a Python file. So I am now literally just working with a regular Python file in an editor, and this is the workflow I'm familiar with. One thing that's interesting to point out is not only we extract all the code, but also we kept the cell structures. You see, no, this is not touch screen. But you can see here we have a special comment that's %%, and this says markdown, meaning this is a markdown cell. So we preserve that structure, and down here I have code cell that only has %% as the comment. And then you can see that we have visually highlighted the current cell, just like how in notebooks, you know which cell you're working in. As my mouse moves over to the next cell, you see the blue bars that goes with that. And what's even cooler about keeping the data structures is that the fact that we have all those links that says run cell automatically light up in VS Code, and I can click on them to get a Jupyter-like experience, but inside an editor. So here I have my markdown node here. Moving down here, I can run a code cell. And to see the same pictures that Catherine has shown you earlier. So now you can take advantage of the power of Jupyter Notebooks and an editor all in one tool. So in here, this window, what we call Python Interactive, it is really a console, what we call Jupyter/IPython console window, which means you can start typing code right in here. If you want to just explore something quick without going to the editor, you can do that, typing a line of code, and press Shift-Enter. You can run that right here. We also got a variable explorer up here, so you can look at all the variables in the current running session, the Jupyter session. So actually what happens when I click on the Run Cell button is we spin off a Jupyter server on your local box. And that's what's used to execute all the code in here. And then here you could do a few things like interrupt the kernel or restart the kernel, just like you would do in Jupyter Notebooks. But also when you're done with your notebook, your code editing, you could also, if you need to, export everything from here back into a Jupyter Notebook. Say if you want to share it with someone or for reporting purposes, you can do so, kind of as a way to go back to the notebooks. All right, let me actually save this file real quick. All right, so what I wanted to do is, since we're talking about turning this notebook into production, right, I might want to make some Python modules for later training. If I get more data, I want to retrain. That's something more easier to work with, other Python modules or packages, instead of this long file that has all those individual functions. So once you're in VS Code, of course, all of the editing features start to light up. IntelliSense or refactoring features. So for example, if I wanted to extract this method, these lines of code into a method, I can do so by doing right-click, and I can do extract method or extract variable, or I can rename all the occurrences or rename symbol. So there's a bunch of features that will help you refactor features easily. And the best part of it is it's so easy now to move code across different cells because everything is just in a text, in a Python file. And of course, there's a debugger integrated in here that's like one click away, right? right there, you can simply hit play button to debug if you need to. So I'm not going to go through each step here on stage. And instead, I'm just going to show you a version that I did kind of cleaned up a little bit earlier. So in here, I have moved all the import statements up to the top. I have turned all these code into different functions. And at the end of it, I do the same thing, which is to register my model with Azure Machine Learning Service, because I wanted to turn that into a web service later. But now I have a clean, nice Python module that can be called from other code based on the notebook that Catherine handed to me. All right, so we talked about refactoring features. Now let's look at how we can move on to the next task, which is how we take that model, turn that into a web service that we can use for prediction. As mentioned earlier, we are using the Azure Machine Learning Service. And then you can work with the Azure Machine Learning Service from within VS Code as well by using this extension called Azure Machine Learning Extension. So I already have that installed. What's great about that tool is now you can see everything from here inside VS Code. You can see the compute, the machines that you use for training right here. You can create a new compute right here. And we can see models right here. These are the models we have taken from our training runs and then registered with the service, so it's all in one central space. So how to turn a model into a service? It's super easy. It's one single click. Can you believe that? Right-click on a model inside VS Code. I apologize for the small font. But this last menu item says, deploy service from registered model. And that is, ooh, that went away. But that is the one thing you need to do. But before we do that, there are two things we need to provide. So think about this. We have a model file, right? Different formats depending on different frameworks you use. And we want to turn that into a web service. But the web service doesn't have any knowledge of your model, right? It doesn't know how to use it. So that's what we need to define in what we call a scoring file. So this is a concept that's part of the Azure Machine Learning Service. So basically what this file does is defines how the web service should interpret the data that's coming in, right? It's an image. In this case, we know that, but the web service doesn't. So you need to tell it that. Second, you need to tell the web service how to use the model, how to use the model to process on the data. And then third thing is the web service needs to know what to send back. Like, what are you looking for? What do you want me to predict? So all that is defined in the score file. There are really only two functions that's key here. One is init. That is when the web service initially starts up. So all we do here is to say, hey, this is the model you need to use as part of this web service. And the run function gets called every time a new request comes to that web service. So this piece of code would define, hey, how we turn the raw data, which is a JSON blob, into an image, right? So in this case, that would be the first step. So in this case, we are using TensorFlow to kind of unpack that, decode that image, turn that into a JPEG file. Actually, let me do one thing real quick. I noticed there's a comment here that says resize image. Let's see if I can write some code right here. Resize. And then as we type, you see that we got IntelliSense right there. On the right side, there's documentation right there. And then as I press start, you'll notice that I have got 5 starred results. That's coming from AI-powered IntelliSense, what we call IntelliCode. So that is also an AI-powered model that has been trained a lot of open source projects to figure out, to understand the pattern for what is the next function you are likely going to use. So in this case, I'm going to type in image, which is one of the 5 start results. And I press dot again really I just want to resize, which is exactly what this model is predicting I am going to do. So all I'm going to do is to tab. So ideally, I don't have to type. I just need to do dot and tab all the way, and my code is written for me.
AI building AI.
Yes. Let me do this quick, and then I just passing resize the image to be what the model, what the MobileNet model needs it to be. All right, so down here, we're going to start a TensorFlow session to have it up running. And then down here, we send back the results, the prediction results, as part of the web service definition. And that's all we need in the scoring file. Okay, so the second thing we want to do is to define the environment in which the model is going to run. So for example, in our case, we need TensorFlow to be there for the model to be function. So this is defined in a YAML file. Pretty straightforward. As you read it, it defines, lists out all the dependencies we're going to need in that environment. And that's all we need to do. So along with those two files, we can go back here and simply click on the model and say deploy. This takes about 6-7 minutes to finish, because this is going to start up a container instance in Azure. It's going to pull in all the dependencies, get the model over, and get the service up running. So that takes about a few minutes. So I'm not going to do that just for time's sake. I'm going to show you a service that has been deployed earlier using the same model. Now, down here in deployments is where you see all the up-running services you have. Inside Visual Studio Code, you can simply right-click and say, View My Service Properties. This is going to pull the latest status of the service. So let's see what we have got here. There we go. There's a scoring URL. So at the end of the deployment, I am going to get this URL, which I am able to use for making predictions. So this is the service we're going to use. All right, so remember it's 24 to 29. Just to show you, this is happening in real time, real service. You can send a picture to that service too. All right. Now, let's go to a test application. All right. So this is a completely separate application that happens to be written in Python as well. This is pretty straightforward. I'm using a random picture, a dog picture from the internet. I'm going to download that. And then I'm going to send it to this service. I turn that into a JSON blob, and then send that JSON blob to the service. 24 to 29. That was the service we looked at. All right, let me see if I can get this to work. Uh-oh, not so good. All right, let's close this. I wonder, Catherine, if you can help me here.
I'd love to help.
All right, let me see. What's the easiest way to collaborate? Let's try this feature called Visual Studio Live Share for real-time editing. Co-editing and co-debugging. Let's try it. I've never done that on stage. That's probably the riskiest part of our demo. Let's try it. I'm going to click here, coming here. So I have the Live Share extension for VS Code installed. Okay, so I got this tab here, and I'm going to say Start Collaboration. It is going to generate the URL, and I'm going to copy it, and then send it to Catherine. All right.
Clearly, we haven't done this before.
No.
By all the links.
See, we practiced. All right, let's go back there. Okay. Too bad we don't have two screens, so you can't really see what's happening on Catherine's machine, but you can kind of get an idea as she joins.
So once I click on the link from wrong, I'm basically popped into Visual Studio Code. and it's loading up her environment.
Oh, you see that? The message down there that says Kathleen has just joined.
Hello.
All right, there you are. She's moving my cursor. Now I'm totally hands off my keyboard. It's all hers.
So,
all right. So actually, let me show you first what's happening, okay? Let me run this cell. Okay, so you guys are going to see the same thing you've seen before, but what's happening on Catherine's machine is her interactive window starts up automatically, and she's seeing the same error. All right, I'm just going to go get a coffee and let Catherine work on this issue, fix my bug.
Yeah, it looks like we have an issue with line 13. And I'd love to see, what does this look like in the variable explorer?
Oh, should I open the variable explorer?
Yeah. Let's open that up and see the type of that URL we're working with.
Oh, okay. So what I'm looking at? Oh, this URL?
Yep. So it looks like that's, yeah, we're looking for a string, and it doesn't look to be a string.
Oh, God.
Yeah, that's all right.
It's
always
response.
those bugs, yep.
Okay, I'll let you.
Yeah, so then
fix it.
I wonder if we just add a dot read here, if that will help things. And it doesn't show up on wrong screen, but on my screen, I'm actually getting the IntelliSense as well. Okay, so let me try that. And if I run this cell, let's see if that helps.
Oh,
yep,
yeah.
I just ran it.
Got it.
Yeah.
Awesome. It worked.
You're welcome.
So that's good. Have someone do my work. All right, now I can take over from here. I can keep running. And that works. And that same result is showing up on her screen as well. That's awesome. Thank you so much for the help.
I'm so smart.
All right, let me stop this session for now. All right, so my app is running great locally. Everything is working. But notice I'm running on a Mac laptop, and my production environment is Linux, and I really want to test out in a Linux environment because I want to make sure it's going to work in production. What would be the easiest way to get a Linux environment set up, to get my code over there and have everything up running? Any thoughts? What's that? Docker, yes. Awesome. What if I say we can get everything up running within minutes inside VS Code?
I don't believe it.
No? How much do you want to bet? All right. So let me open my Explorer. Let me show you my secret Docker image here. So what I have is I have a folder named .devcontainer. This is part of the Visual Studio Remote Development Support. So once you have a .container folder here, Visual Studio Code says, oh, okay, you want to build a container. I know how to do that. So up in here, there are a few files, but they are all pretty straightforward. This simply defines what my container looks like and what is the Docker file that the VS Code should use to build that image. What extensions I want in the container, okay? So those are the few things. And if you look at the Docker file, this is like any other Docker files. So what we're using is a Linux-based image with Anaconda pre-installed. So we are likely going to use those packages. Up here, we are going to copy settings, a setting file, which we're going to look at a little bit later. Get everything updated, and I simply added this just so I have an environment pre-installed with all the packages I'm going to need for this test app. And then we make a directory in the container. What happens is VS Code is going to automatically mount everything from my local box into the container image. And then we do some other Python dependencies, and then we finally clean up. So this is just a standard Docker file. And the last thing I want to show you quick is the settings file. This is interesting. This allows you to define different settings for VS Code for the one that's going to run inside the container. And that can be different from my local settings. So you can do whatever you want differently in the container. So one thing I wanted to have differently is my theme, my color theme for VS Code. So right now, locally, I'm running in dark theme. but I have defined that in the Docker, in the remote container, I wanted to use light theme. So just so it visually differentiates the different environments, right? So that's all I have. That's it. And then single click, the magic button is down there. The little green arrow thing that says open remote window. So VS Code Remote allows you to connect to 3 different remote environments. One is it could be any machine that you can SSH into. 2 is Docker containers. 3 is Windows subsystem for Linux, WSL. So what I'm going to show here is we are going to use the container. So I simply say, reopen this folder in the container. So if you run this for the first time, I do want to save it. It is going to build that container image based on what I had defined. Yay, my theme light up. OK, so this, I need to select the environment, which I have pre-created. That is my, I don't know what this area is. Let's pretend that didn't happen. All right, so now you can see down here it says dev container, Python 3 Anaconda. This is the name of my container. And this tells me I am now working in the container environment. Okay? Let's see if our little test app still works. Finger crossed. What is it, like 3 minutes? 5? All right, our image. This is running in a Linux container now. And then we can get results back as well. So this is all testing against that service. So it doesn't matter which OS, but I just want to make sure in this consistent environment, it is going to work. All right, cool. So that's all the demos we want to do. Let's go back to recap what we have seen. All right, let's move forward. OK, so we used the Visual Studio Code for a few tasks that is centered around Python development. So you can import, export Jupyter Notebooks. I talked about you can visualize data frames and plots. And in our case, we looked at the images inside the interactive window. We have got a variable explorer for viewing variables in the Jupyter session. It is, this window is literally just a console in which you can type in code and execute. We have refactoring features, IntelliSense, debugging, all that integrated in that one tool. We have tried out live share for real-time collaboration. And then finally, we talked about remote development. And just to elaborate a little bit more on remote development, so this, we have an extension for VS Code called remote development. So if you want to give that a try, go search for remote development. And that is the extension that will empower you to connect to any remote machines or container or Linux system in Windows. So really what happens is we have UI theme-based extensions running locally, but everything else, all the heavy lifting or the source code, everything happens on the remote machine, as this chart illustrates. And then model deployment. What we used is the Azure Machine Learning extension for VS Code, which allows you to work with Azure Machine Learning Service, everything from within the VS Code editor. You can manage workspaces, submit training jobs, like the training jobs that Catherine submitted from the notebook earlier. You can do that in VS Code as well. You can register models, look at models, turn models into services. Pretty much everything you can do on the Azure portal, you can do in VS Code as well. So if you're already in that environment, you don't have to leave the tool to do something else. All right. So what's next? You could build your own pet detector, feed it with your own data set, and maybe try some other images. You can make something fun out of it. So like Catherine said, everything is on GitHub repo. Feel free to clone and give that a try. These are links to, one is Azure Notebooks. The second one goes to the VS Code AI specific tools. And yeah, some additional resources, but at the same time, we have about 10 minutes left. Happy to take any questions, any comments, thoughts, like what you have seen.
Yes.
Awesome, thank you. Any questions, feel free to use the mic.
We'll hang around up front as well.
Yeah.
Will it work in Visual Studio?
Will this work in Visual Studio?
All the same tools, same connectivity and stuff.
That is a great question. You're talking about specifically about remote, right? Remote development.
Well, everything, the Python.
So we do have Python support in Visual Studio, which will allow you to do things similar. There's an interactive window. You can look at the plots and data frames and stuff like that. And we do have live share support in Visual Studio as well. But regarding the remote development, I think this is new to VS Code. I don't think it's in VS yet.
Okay, thank you.
Sure.
I'm especially interested in that part of the deep learning. So you see the Microsoft, that the machine learning service there. Do you have more details there? We can
Azure
share
Machine
with
Learning
us?
Service?
Yeah.
Yeah, can you go back? Do you want to go back to the previous slide? No, the resources.
Oh, sorry.
Oh, we don't have that one here.
Just AML.
Yeah, the Azure Machine Learning Service. Do you want to bring up a browser, maybe search for?
Sure.
So is there anything specific about Azure Machine Learning Service you're interested in?
Yes, because of your thing about something machine learning versus the deep learning, that one, the deep learning don't have to match the human interaction, which is that machine taking care of that one itself, right? So machine learning, on the other hand, you have to label it, understand it, and then the machine doing something, training, and doing something. So many human interactive there, but deep learning, it is not. So I want to know more about that kind of details there.
Okay, so let me try to see if I understand your question. So you're trying to understand how specifically Azure Machine Learning Service is helping making deep learning easier, like labeling data and stuff like that.
Actually, is that how deep learning, without human interaction, it can be based on just information you send to. It can tell what should be positive output, what should be negative subsequence.
Right.
I want to know more about that.
Okay. So unfortunately, labeling data is still something that humans would have to do.
Exactly, yeah.
Right. I know there are some tools out there that could help automate that process, but I'm not super familiar with that. I think the most value where Azure Machine Learning Service can help is really when it comes to training and inferencing. Right now, it doesn't do much beyond like regular data storage for you in the data exploration phase. So that is pretty much still up to you as the human expert to kind of label the original data.
But I would definitely, keep an eye on that area because it's something they're thinking about and want to help.
That is definitely a big pain point there.
Yeah.
Most time consuming. So your question is if we can share latest updates on the service in the GitHub repo? Right. Oh yeah. Do you want to bring up the GitHub page?
Yep.
Do we have links? We should have links to the Azure Machine Learning Service, I'm pretty sure.
Yeah, so we talk about something NVIDIA's
No?
Do we not? Yeah, we don't have something specifically to AML, but we can easily add that if that's helpful.
Yeah, that's a good point.
Yep.
Thank you.
Thanks.
You mentioned convolutional neural networks for image processing. What are the other types of neural networks, I guess, for stuff like time series data or other types of data, I guess, other than images?
So there's the, what's that called, recurrent neural network.
RNNs.
RNNs, those are mostly for being able, like CNN doesn't have any knowledge of what happened in the past, but RNN can help with that.
Okay.
Like it helps with language processing because you need to have the context. That would definitely help there.
Do the layers and stuff that you guys mentioned, I guess, that doesn't seem like it would necessarily apply as well to that?
Hidden layers?
Or the layers that happen in the convolutional neural network.
Right.
I guess.
That's specific to the CNN network.
Right. Okay.
But there are many different implementations of the CNN network because it's just a concept.
I see.
There are different architectures for how to go implement that. And one of those, I think, is probably the most efficient is called ResNet.
Okay.
ResNet also has different variations depending on how many layers you want to go with. For smaller devices, you might want to go with something that has less layers, so the size would fit. But of course, with less layers, you have lower accuracy, so it's a trade-off. Okay. So I would definitely recommend looking at ResNet as one of the CNN implementations.
Thank you.
Thank you.
Hey there.
Hi.
I actually found this repo last night, and I was going through this
Oh,
in advance.
cool.
Ahead of the game.
You skipped over the compute portion of this, and it's actually where I got stuck. So
Okay.
there's a suggestion like use a data science virtual machine, and, and it has a GPU. And then when you go to attach your Jupyter notebook to compute, it's like put your username and password, and it's like listening on 8,000. And I noticed by default my data science VM didn't seem to be listening on 8,000. It wouldn't connect my Jupyter notebooks. I know this is a specific scenario, but I guess generally the question is there any provisioning you have to do to your VM or your infrastructure in order to get this to run, or you should just be able to click the drop down and attach compute?
Yeah, you should just be able to click the drop down because a data science virtual machine, rather as opposed to just like a vanilla Azure VM, will open up port 8000 for Jupyter. So it should be up automatically. I know sometimes if you had just deployed the VM, it might not be up if you go to Azure Notebooks, so there might be like a bit of lag time. So you might see like a one-off error, like if it says like port 8000 is not open yet, or if you got that error. Should work if you just retry it.
I noticed it was listening like on 8001, and I was like, oh, this is weird. And when you go to connect the compute, there's a text box to change the port, but then you can't actually change the port. So I don't know. It's
it should stay on, like if we do this.
Yeah, exactly.
So you should stay on 8000.
I thought maybe the image for the data science VM might have been updated since this repo was published or something. I wasn't sure. Maybe it's just a.
I can look at it with you right now if you want, because it should work with this, but we can debug it if it's not, because this default should be good.
Cool.
Yeah.
All right.
All right. Thanks, everyone.